Hi, this is Will Murray, and I'm going to be giving the trigonometry lectures for educator.com. We're very excited about the trigonometry series. In particular, for me, trigonometry is the class that got me excited about math, so I'm really looking forward to working with you on learning some trigonometry. We're going to start right away here learning about angles. And the first thing you have to understand is that there's two different ways to measure angles. People use degrees, which you probably already heard of, and radians, which you may not hear about until you start to take your first trigonometry class. So they're just two different ways of measuring. You can use either one, but you really need to know how to use both and convert back and forth. So that's what I'll be covering in this first lecture. We'll start with degrees. Degrees are a unit of measurement in which a circle gets divided into 360 degrees. So if you have a full circle, the whole thing is 360 degrees. That's 360 degrees. And then if you have just a piece of a circle, then it gets broken up into smaller chunks. So for example, an angle that's half of a circle here, that's 180 degrees, because that's half of 360. Quarter of a circle, which is a right angle, that would be 90 degrees, and then so on. You can break those angles up into even smaller pieces. You can take a 90-degree angle and break it up into two equal pieces, and then each one of those pieces would be a 45-degree angle. Or you could break up a 90-degree angle into three equal pieces, and each one of those would be a 30-degree angle. So we'll be studying trigonometric functions of these different angles, but in the meantime, it's important just to get comfortable with measuring angles in terms of degrees. The second unit of measurement we're going to use to measure angles is called radians, and that's a little bit more complicated. You probably haven't learned about these until you start to study trigonometry. But the idea is that you take a circle, and remember that the circumference of a circle is equal to 2 pi times the radius. That's 2 pi r is one of those formulas you learn in geometry. What you do with radians is you break the circle up and you say the entire circle is 2 pi radians. 2 pi radians. What that means is that a 1 radian angle, well, if the entire circle is 2 pi radians, then 1 radian, use a little r to specify the radians, cuts off an arc that is 1 over 2 pi of the whole circle. So 1 radian, an angle that is 1 radian cuts off a fraction of the circle that is 1 over 2 pi. And since the radius is 2 pi times r, sorry, the circumference is 2 pi times r, if you have 1 over 2 pi of that, if you have 1 over 2 pi of the whole circumference, what you get is exactly the length of the radius. So that's why they're called radians, is because if you take a 1 radian angle, it cuts off an arc length that is exactly equal to the radius. So that's the definition of radians. It takes a little bit of getting used to. What you have to remember that's important is that the whole circle is 2 pi radians. That means a half circle, 180-degree angle, is pi radians. A right angle, a 90-degree angle, or a quarter circle, is pi over 2 radians, and so on. And then you can break that down into the even smaller angles like we talked about before. If you take a right angle and you cut it in half, so that was a 45-degree angle before, that's pi over 4 radians, because it's half of pi over 2. If you take a right angle and you cut it into 3 equal pieces, so those were 30-degree angles before, in terms of radians, that's pi over 2 divided by 3, so that's pi over 6 radians. So you want to practice going back and forth between degrees and radians and kind of getting an intuitive feel for how big angles are in terms of degrees and radians. And we'll practice some of that here in this lecture. Remember that pi is about 3.14. So 2 pi is about 6.28. So that means we're breaking an entire circle up into 2 pi radians. So the circle gets broken up into about 6.28 radians. So that means that 1 radian is about 1/6 of a circle. So what I've shown up here is pretty accurate. The 1 radian is about 1/6 of a circle. It's about 60 degrees, but it's not exact there because it's not exactly 6. It's 6.28 something. So that's about roughly a radian is about 60 degrees, but we really don't usually talk about whole numbers of radians. People almost always talk about radians in multiples of pi, the same way I was doing here, where I said the circle is 2 pi radians, the half circle is pi radians, the right angle is pi over 2. So people almost always talk about radians in multiples of pi and degrees in terms of whole numbers. So sometimes they don't even bother to write the little r. It's just understood that if you're using a multiple of pi, then you're probably talking about radians. So let's practice going back and forth between degrees and radians. Remember that 360 degrees is a whole circle, and that's 2 pi radians. What that means is that pi radians is equal to 360 degrees over 2, which is 180 degrees. So pi radians is 180 degrees. So that gives you the formula to convert back and forth between degree measurement and radian measurement. If you know the measurement in degrees, you multiply by pi over 180, and that tells you the measurement in radians. If you know the measurement in radians, you just multiply by 180 over pi, and that tells you the measurement in degrees. We'll practice that in some of the examples later on. We got a few more definitions here. Coterminal angles. What that means is that they're angles that differ from each other by a multiple of 2 pi radians. Remember, that's a whole circle, or if you think about it in degrees, 360 degrees. So for example, if you take a 45-degree angle, and then you add on 360 degrees, that would count as a 360 plus 45 is 405 degrees. So 45 and 405 degrees are coterminal. In the language of radians, 45 degrees is pi over 4. And if you add on 2 pi radians, if you add on a whole circle to that, you would get, oops, this should end up here. If you add on 2 pi plus pi over 4, well, 2 pi is 8 pi over 4, so you get 9 pi over 4. Then pi over 4 and 9 pi over 4 are coterminal angles. The reason they're called coterminal angles is because we often draw angles starting with one side on the positive x-axis. So we start with one side on the positive x-axis. I'll draw this in blue. And then we draw the other side of the angle just wherever it ends up. And so coterminal angles are angles that will end up at the same place. That's why they're called coterminal. So if they differ from each other, if one is 2 pi more than the other one, or 360 degrees more than the other one, or maybe 720 degrees more than the other one, then we call them coterminal because they really end up on the same terminal line here. A couple other definitions we need to learn. Complementary angles are angles that add up to being a right angle. In other words, 90 degrees or pi over 2. So if you have two angles, like these two angles right here, that add up to being a right angle, 90 degrees or pi over 2, those are complementary. And supplementary angles are angles that add up to being a straight line. In other words, pi radians or 180 degrees. So those two angles right there are supplementary. So that's all the vocabulary that you need to learn about angles, but we'll go through and we'll do some examples of each one to give you some practice. So here's our first example. If a circle is divided into 18 equal angles, how big is each one in degrees and radians? So let me try drawing this. And we've got this circle, and it's divided into a whole bunch of little angles, but each one is the same, and we want to figure out how big each one is in terms of degrees and radians. So let's solve this in degrees first. Remember that a circle is 360 degrees, and if it's divided into 18 parts, then each part will be 20 degrees. So each one of those angles will be 20 degrees. So we've done the degree one. How about radians? Remember that an entire circle is 2 pi radians. So if we divide that by 18, then we get pi over 9 radians will be the size of each one of those little angles. So you can measure this angle either way. We say 20 degrees is equal to pi over 9 radians. Second example here, we want to convert back and forth between degrees and radians. So let's practice that. We want to convert 27 degrees into radians. Well, let's remember the formula here. The conversion formula is pi over 180. So we do 27 times pi over 180. That's our conversion formula from degrees into radians. And I'm just going to leave the pi because it doesn't really cancel with anything. The 27 over 180 does simplify. I could take a 9 out of each one, so that would be 3. And if we take a 9 out of 180, then there'd be 20. So what we end up with is 3 pi over 20 radians as our answer there. So converting back and forth between degrees and radians is just a matter of remembering this conversion factor. Pi over 180 gets you from degrees into radians. And for the second part of this example, we're given a radian angle measurement, 5 pi over 12, and we want to convert that into degrees. 5 pi over 12 radians. So we just multiply by the opposite conversion factor, 180 over pi. And let's see here, the pi's cancel. 180 over 12 is 15. So that's 5 times 15 degrees. And that gives us 75 degrees. So the same angle that you would measure in radians as being 5 pi over 12 would come out to be a 75 degree angle. So converting back and forth there is just a matter of remembering the pi and the 180 and multiplying by one over the other to convert back and forth. Third example is some practice with coterminal angles. In each case, what we want to do is we're given an angle and we want to find out what quadrant it's in. That's assuming that all the angles are drawn in the standard position with their starting side on the positive x-axis. So we want to start on the positive x-axis and we want to see which one of the 4 quadrants the angle ends up in. And then we want to try to simplify these angles down by finding a coterminal angle that's between 0 and 360 or between 0 and 2 pi radians. So let's start out with 1,000 degrees. 1,000 degrees is going to be, that's way bigger than 360. So let me just start subtracting multiples of 360 from that. So if I take off 360 degrees, what I'm left with is 640 degrees. That's still way bigger than 360. I'll subtract off another 360 degrees. And what I'm left with is 280 degrees. Now, that's between 0 and 360. So I've found my coterminal angle there. I want to figure out which quadrant it's going to end up in. Now, remember, if we start with 0 degrees being on the x-axis, that would make 90 degrees being on the positive y-axis. And then over here on the negative x-axis, we'd have 180 degrees. And down here, 270 degrees, because that's 180 plus 90. And then 360 degrees would be back here at 0 degrees. So 280 degrees would be just past 270 degrees. It's a little bit bigger than 270 degrees. So it would be about right there. So that's 280. And so that puts it in the fourth quadrant. Okay, the next one's a radian problem. We have negative 19 pi over 6 radians. So that's one, I'll do this one in red. That's one that goes in the negative direction. So again, we start on the positive x-axis, but now we go in the negative direction. So instead of going up around past the positive y-axis, we go down in the negative direction, and we go negative 19 pi over 6. Well, if you think about it, 19 pi over 6 is bigger than 2 pi. So let me start with 19 pi over 6 and subtract off a 2 pi there. Well, 2 pi is 12 pi over 6, so that gives us 7 pi over 6. But if we do negative 19 pi over 6, plus 2 pi, that's going to give us negative 19 pi over 6 plus 12 pi over 6 is negative 7 pi over 6. And that's still not in the range that we want because we want it to be between 0 and 2 pi radians. So let me add on another 2 pi. Plus 2 pi gives us positive 5 pi over 6. So the trick with finding these coterminal angles, with the degrees, it was just a matter of adding or subtracting 360 degrees at a time. With radians, it's a matter of adding or subtracting 2 pi radians at a time, because remember, 2 pi is a whole circle. So we end up with 5 pi over 6. So that is between 0 and 2 pi, so we're done with that part. But we still have to figure out what quadrant it's in. Well, now 5 pi over 6, where will that be? Well, if we map out our quadrants here, 0 is right there on the positive x-axis, just as we had before. 90 degrees is pi over 2 radians. 180 degrees is pi radians. And 270 degrees is 3 pi over 2 radians. And then 360 degrees is 2 pi radians, a full circle. So where does 5 pi over 6 land? Well, that's bigger than pi over 2. It's less than pi. So 5 pi over 6 lands about right there. And that's in the second quadrant. Okay, now we have another degree one. Negative 586 degrees. Again, what are we going to do with that? It's going in the negative direction, so it's going down south from the x-axis. Negative 586 degrees. Well, 586 is way outside our range of 0 and 360. So let's try adding 360 degrees to that. and that gives you negative 226 degrees, which is still outside of our range. So let's add another 360 degrees. Remember, we're adding and subtracting multiples of a full circle, 360 degrees, and that gives us positive 134 degrees. Now, positive 134 degrees, that is in our allowed range between 0 and 360. So we've finished that part of the problem. Where will that land in terms of quadrants? Let me redraw my axes because those are getting a little messy. So that's 0, 90, 180, 270, and 360. Where is 134 going to be? 134 is going to be between 90 and 180, almost exactly halfway between. So it's about right there. That's in the second quadrant. So the answer to that one is that that's in the quadrant number 2 there. So finally, we have 22 pi over 7, again given in radians. And the question is that between 0 and 2 pi? And it's not. It's too big. It's bigger than 2 pi. So let me subtract off a multiple of 2 pi. I'll subtract off just 2 pi, which is 14 pi over 7. So that simplifies down to 22 pi over 7 minus 14 pi over 7 is 8 pi over 7. Now 8 pi over 7 is between 0 and 2 pi. So we found our coterminal angle. Where will that land on the axes? Well, remember, 0 degrees is 0 radians, 90 degrees is pi over 2 radians, 180 degrees is pi radians, and 270 degrees is 3 pi over 2 radians. And finally, 360 degrees is 2 pi radians. 8 pi over 7 is just a little bit bigger than 1. So that's a little bit, or 8 over 7 is a little bigger than 1. So 8 pi over 7 is just a little bit bigger than pi. So that's going to put it about right there, which will put it in the third quadrant. So let's recap how we found these coterminal angles. Basically, you're given some angle and you check first whether it's in the correct range, whether it's in between 0 and 2 pi radians, or if it's given in degrees, whether it's between 0 and 360 degrees. If it's not already in the correct range, if it's negative or if it's too big, then what you do is you add and subtract multiples of 360 degrees or 2 pi radians until you get it into the correct range, the range between 0 and 360 degrees or 0 and 2 pi radians. And once you get it in that range, if you want to figure out what quadrant it's in, well, in degrees, it's a matter of checking 0, 90, 180, 270, and 360. In radians, it's a matter of checking 0, pi over 2, pi, 3 pi over 2, 2 pi. Which one of those ranges does it fall into? That tells you what quadrant it's in.